Welcome to 10.5 video lesson algebra 2. The concept here we're going to talk about is the hyperbola, and there are 7 boxes for us to talk about. So box number 1 is sort of just a generalization of remembering where the hyperbola comes from. In the first video I showed you like where all the conic sections come from, but let's focus primarily right now on the hyperbola. So in picture number 1, you can see if you have these two cones that are upside down on each other, and you take a plane and you slice the cones parallel to the vertical axis on the cones themselves, then the part that is left over, the piece that you cut away, is the hyperbola. And I like picture number 2. You can kind of see like this person sort of cutting away at at these two cones here, this vertical alignment, and you get to see the outline of the picture here and here. And then when you actually look at this in 2 dimensions, basically just putting this image onto a graph, the 2 ways that we're going to talk about a hyperbola are hyperbolas that go sort of open left and right like this one does, and then open up and down like this one does. So this is just a generalization of where the hyperbola comes from, and the 2 ways that we're going to study it. It's going to be left and right or up and down when you put these in the plane. So this is just sort of an introduction to where the hyperbola comes from. Okay, box number 2 is all about the parts of the hyperbola. So similar to the way that I introduced to you all the parts of the ellipse, I'm going to introduce to you all the parts of the hyperbola. So this is one way that the hyperbola can open. It can kind of go left and right. It can also go up and down, but the parts are going to be the same. So first, let's talk about the center. Okay, the center, of course, is, what you might think it'd be. It's located at the center. A hyperbola has 2 vertices. One on the right hand side and one on the left hand side, and of course it will be in line with the center. Okay, it has 2 focal points just like the ellipse. The only difference is though the focal points are further away than the vertices on a hyperbola than they were on the ellipse. You may recall that the focal points are inside the center and the vertex for the ellipse, but they're outside like you see here for the hyperbola. Okay, the transverse axis is the longer of the 2 axes. The transverse axis is the one that has the focal points, the vertices, the center, and then the focal points again. That's your transverse axis. Your conjugate axis is the one that is perpendicular to your transverse axis. You're not going to hear me use those words, transverse and conjugate. You're just going to hear me say either opens left or right or up and down. I think it's a lot easier for students to understand. And then I also come up with this thing called the box. And the box is this sort of outline that I have here. And the box is going to play an important role. It's going to give us the shape of the asymptotes, which then in turn shape the hyperbola. So we're going to talk about that in just in more detail later, but that's when I talk about the top of the box here, this location, and then the bottom of the box, this location. It's really, we're talking about the conjugate axis, but no one really calls it that. The axis of symmetry it can be 2. There are 2 of them, right? If I fold this over itself on the transverse axis, or if I fold it over itself on the conjugate axis, I can see 2 axis of symmetry. So that's something to note. And then lastly, there are these asymptotes here. And the asymptotes are shaped by points that go through the center to the top of the box and then to the right of where a vertex is. This would be one asymptote here. And then the other asymptote would be this one here. And we're going to talk all about this stuff in the next idea. But I just want you to get an understanding of what these words mean in terms of the picture here. And then there's this relationship, which I'm going to talk more about, but in the hyperbola, it was c equals a squared minus b squared, or in the ellipse, rather, it was c squared equals a squared minus b squared. In the hyperbola, it's going to be c squared equals a squared plus b squared. So keep this in mind, and I'm going to talk to you about what the a, the b, and the c are in the next one. But these are all the words that we're going to be using to talk about the hyperbola here. I know that was a lot, so I'll pause it and let you copy down anything you need, and then we'll talk more about detail in the next box. Okay, box 3. Hyperbolas can open 2 ways, meaning they can either be horizontal hyperbolas, like this one here, or they can be vertical hyperbolas, like this one here. So what I mean by opens, like when I mean by horizontal, I mean we're talking about their transverse axis. Either it goes left and right, or it goes up and down, okay? So here we go. Let's talk about all this stuff here. These are the two pictures that we have. First, let's talk about the equations, okay? So let's look here and let's look here. The equation for the hyperbola that's going to open left and right is going to be x squared over a squared plus y squared over b squared equals 1. Now, you're going to notice that that looks a whole lot like an ellipse. The only difference is the sign in the middle is negative. And one thing that helped me learn this stuff is that, okay, if my shape is moving away from each other, like it is here, the shape of the hyperbola is moving away from each other, then the signs have to be negative. If the shape was moving in towards each other, then it would have to be positive, like an ellipse. So that might help you too. And here's how you know, okay? In the ellipse, the a squared was always the bigger one. Whichever way the a squared is, that told you that it opened left or right or up and down. And in this case, the a squared is going to be underneath the positive one, right? Underneath x squared. So because the a squared is underneath the x, that tells me it is a left-right hyperbola. Versus this one, you'll notice the a squared is underneath the y, so it must be an up-down hyperbola. In any case, the a value is going to be the distance from the center to a vertex. So center to vertex or center to vertex. The b is going to be the center to the side of the box or the top of the box. So in this case, center to top of box. In this case, center to side of box. And c is going to be the distance from the center to a focal point. So centered out to a focal point or center out to a focal point. So these three things you got to keep in mind for the values of a, b, and c. And then the relationship is always a squared plus b squared. It's going to be opposite the sign that's inside the equation. I know this is a lot, but we're going to practice with it. It's not that bad once you see it in action, okay? And then the only other thing to consider about is the asymptotes here, all right? The asymptote is just a line, so we can calculate the slope of the line as either being b over a, like it is in this case, or being a over b, as it is in this case. And it's actually, that's not that bad either once you play around with these things. So let me get rid of all this information for you. I think we need to make sure we have these two equations down and maybe a sketch of the pictures and definitely these relationships here. And then we can start doing some examples together. Okay, box number 4. Let me walk you through an example. We're going to write and graph the hyperbola with a center at 0, 0, a vertex at plus or minus 4, 0, and a focal point at 5, 0. Okay, honestly, the best way to do these problems is to graph them and get a visual of what's going on here, okay? Oh, I think I'm going to use black. Okay, here we go, black. All right, so let's get a visual of what's going on here. The center's at 0, 0. Okay, no problem. There's my center. A vertex is at plus or minus 4. So 1, 2, 3, 4. So that's going to be vertex number 1. Doesn't matter if you call it 1 or 2. And then 1, 2, 3, 4. That's vertex number 2. So automatically I know center to vertex, this is going to be a value of a, and my a is going to be 4 units. Okay, focal point is at 5. So if I go back to my black one and go over here, this is 5 units. So that's a focal point number 1. Over here, focal point number 2. And I know the distance from center to focal point is going to be a value of c. So c is 5 units, okay? So take a look at this. This is going to be, since my center, my vertex, and my focal points are all in a horizontal line, I know the equation is going to be x squared over a squared minus y squared over b squared is equal to 1. I know that a is 4, so a squared is 16. So x squared over 16 minus y squared over b squared is equal to 1. The only thing I don't know is the value of b. But remember the relationship c squared is equal to a squared plus b squared. Remember, these signs are always going to be opposite of what they are that I'm working with here. So I know that, so 25, because c is 5, is equal to a squared, which is going to be 16, plus the b squared. So therefore, 25 minus the 16 is going to be b squared. So that tells me that b squared is going to be equal to 9. So I've got x squared over 16 minus y squared over 9 is equal to 1. So there's my equation. Perfect. Now I'm going to go up 3. 1, 2, 3. Remember, because b is the distance from center to the top of the box. So b is going to be a value of 3. And then I'm going to go down 3. 1, 2, 3. And then from here, the idea is you draw this little box that goes from B to A down to B again. and then over to A, and then back down, and then over like that. So what I've done is I have now created lines for my asymptotes here. So it would look like that, and then it would look like this. Okay, and I know the slope of this line. This is going to be the equation y is equal to the rise is 3, the run is equal to 4, and it's going to be y equals 3/4 x. This one is going to be y equals negative 3/4 x. And then from here, I have all the information that I need to draw the hyperbola. I start from the vertex and I go out and I start to mirror the asymptotes. And then I go down and I start to mirror the asymptotes. Again, start the vertex, go up, mirror the asymptotes, go down, mirror the asymptotes. So that is what we would expect for a sketch and the equation of the hyperbola. And honestly, the best way to do this, you guys, is to draw the graph and pull the information out of the graph. Hopefully this makes sense to you. Okay, box number 5. Let's do another example together. Let's sketch x squared over 49 minus y squared over 64 is equal to 1. Okay, so the first thing we want to do is figure out what are my values of a squared and b squared. So because I know I have a minus sign here, I know I'm going to have a hyperbola. And for the hyperbola, I know that the value of a squared is always going to be underneath the positive one. So in this case, again, 49 is underneath the x squared. So I know this is going to be a left-right hyperbola, even though 64 compared to 49 is bigger, and that's what we would look for in an ellipse. We look for the positive one in the hyperbola here. Okay, so I know this is going to be a left-right. I know it's going to be centered at 0, 0. So here we go. So I'm going to go this, I'm going to do this. And I know that the center to, this is a squared. A squared is equal to 49. So of course, a is equal to plus or minus 7. So 1, 2, 3, 4, 5, 6, 7. That's going to be a vertex. And 1, 2, 3, 4, 5, 6, 7. That's going to be a vertex. Now b squared is equal to 64. So b is equal to plus or minus 8. So I'm going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And now I actually have enough to draw my box because all I need is the a value and the b value. Okay. So now this distance is 8 from here to here, right? And this distance from here is 7. So I know the equation for this asymptote here is going to be y equals 8 over 7x. And the equation for this asymptote here is going to be y equals negative 8 over 7x. And then I actually have enough information now to go ahead and sketch because I have the vertex and I go out and I mirror my asymptote and I go down and I mirror my asymptote. I go up and I mirror the asymptote and I go down and I mirror the asymptote there. The only other thing that I need now are the location of the focal points. And remember that c squared is a squared plus b squared in this case. So c squared is going to be 64 plus my 49. So c squared is going to be 103. If I think I did that right. And then so c is going to be plus or minus the square root of 103, whatever that happens to be. So I can go here and I can say that is plus square root 103 comma 0. And over here minus square root 103 comma 0. So I have given everything that I possibly could and sketched the following, and this is what we would expect. So c squared is going to be 64 plus 49 is 113. So c is equal to plus or minus the square root of 113. So I could say this focal point is at square root 113 comma 0. And this one is at negative square root 113 comma 0. So I've given the location of my focal points, and hopefully this makes sense to you guys. Okay, here's number 6. This is a U-try. I want you to tell me the equation for this hyperbola. So I've given you all the information that you would need. All you gotta do is tell me the equation for the hyperbola. Take a look at that and see if you can come up with it. Okay, then lastly, tell me where the focal points would have to be for the same hyperbola that was in the last box. Where would the focal points have to be? So I'm looking for an XY location of the focal points here. So remember that c squared is equal to a squared plus b squared. So therefore, c squared is going to be 3 squared plus 2 squared, or 9 plus 4. So 13. So square root of 13 is going to be the value of c. So therefore my focal points are at plus or minus rad 13 comma 0, which is around this area, focal point, and around that area, focal point.